Hey guys, this is Hetu and welcome back to etlqalabs. And how are you guys? I hope that you all are doing good and happy Diwali. Today I have come up with a new topic in database. I thought that this topic is important and I'm sure that you might have encountered the questions on this topic, right? So I thought that I can make this a topic in the easiest possible way or manner so that you all can get benefited, right? So let's start with the topic, guys. The topic is database normalization. Database normalization. So what I will do is agenda of this topic is basically I'll try to explain first of all why do we need normalization and what is normalization in database, right? And then what are the different type of normalization that we have in database, right? And then we will take the example and we'll try to cover, right, so that you all will be very clear, right? So let's just start with this introduction part of this and the definition at least, right? So agenda is basically definition. Second one, what we would like to understand is basically why do we need it? Okay, do we need? And the third one is a type of normalization, right? And examples, obviously, right? Example, a real time example. All right. So I think we will try to stick around this agenda and then we will try to understand, guys. Okay. And I'm sure that once you watch this entire video, you will be very crystal clear about this topic and you will be able to answer, the questions related to normalization in your interviews, right? And it's very important if you say that you are good in SQL and you are like you're working on ETL testing or did ETL development, etc. So any person who is working in the database background, I think the person should know this normalization. I would not say this is the very easiest. I mean the basic level, but I would say it's basic to intermediate level kind of concepts that we should be aware of it, right? So let's start this topic, guys. So first we will try to understand the normalization. So what is normalization, right? So normalization, okay. It's basically normalization is it's a database design technique, guys. Okay. So it's a database design technique which help which helps to reduce or remove redundancy. So this is the definition, guys. Okay, I'll try to explain what is redundancy, etc. But just know that this is a design technique, database design technique, and this is, guys, I'll tell you. So there are two. You know, this design technique is used when the database is first time designed, the tables are first time designed. Maybe it's basically applied by the architect levels, right? The people who actually do the architecting of the table, data modeling, etc. So this is normally being used, and they keep this in mind while they design the entire database for the projects, etc. Right? So what it does, it basically uh, provides certain sort of different rules, right? And those rules, when we apply while designing this, obviously when I say we, means it's a data modeler or a database, what do you say, project database engineers, etc., whoever is responsible for designing the table, etc., right? So they will keep this in mind when they design this, right? So this will actually help you to ensure that there is no redundancy. Redundancy, when I say, it's like a duplicate, right? Duplicacy, right? So redundancy, it will help to remove, when you apply these rules, it will help to remove any sort of duplication of the data, right? So this is as simple as that. Okay, guys. Now we will see how it will help and all. Don't just don't think too much complicated about it. But it's just that you know that this is just a technique, and it will help you to create a better database, and it will help you remove the redundancy, or it can also remove the redundancy. All right. I think you are clear with this topic right now. I mean, at least the definition part you are okay. All right. Now let's see why do we need it, right? So as I said that why do we need it? We want to basically we want to have the database, okay, clean database, okay. Second, optimized. Second, guys, optimized data model, right? Or optimized and efficient, you can say, right? Efficient. Because if are you are clear, if you are applying all those rules to design your database, then it will be very optimized and efficient, right, for you, and it will not have a duplicacy, etc., right? So it will duplication. Duplication. Okay, so these are the certain benefits basically, just to understand why do we need it, right? And when do we need it? Because when the the database is designed on the project level, or even let's say if you are actually doing some sort of optimization of the database itself, like later the database design has been done wrongly, and later you realize that this is not something that it is supposed to. Let's say there is some major performance bottleneck, right? Or some issue with the database, right, with regards to performance or with regards to managing it, etc. Then people may realize that okay, we need to optimize this database, or we need to redesign the entire data modeling. Correct. In that case also, these techniques can be applied. Okay. So I mean, this is just technique you can apply, and at any stage of your entire life cycle of the project, right? So just technique, right? Now we will try to understand what are the types of normalization, guys, first. Okay. So types of normalization. So guys, we have actually, I think, six different type of normalization. I think six or seven. So I'll just tell you first. Know that how many types. So first is one NF. They are NF means normal form, right? Normal normal form. Okay, this is called NF, guys, in short form. Okay, so in interview they might ask, can you give me the example of one NF, or one normal form, first normal form, right? First normal form, I would say here. Second normal form, third normal form. So this is like this. All right. So this is first normal form. So there are two. Second, guys. Second, then third normal form, 2NF. All right, 3NF, and then guys there is something called BCNF. Okay, so first of all I'll tell you, I think I missed to tell you. So this basically technique was first time invented, or I would say this discovered by the database father of the database, right? So who is the father of the database technique, right? Who is that? His name is EF Cod, guys. Okay, EF Cod. So he actually used the first time this particular technique, 1NF technique, normalization technique, and later it got expanded, and many other people came and contributed it, right? So these are certain rules. So these are nothing but they are the rule set, rule set for database design. Okay, guys. Okay. So we will discuss all of those rules, okay, and what it should, have, what should not. So BCNF is basically its full form is Boys Code Normal Form, okay, BCNF, guys. All right, and then you have got 4NF, okay, fifth NF, and then 6NF. Until now we have 6NF, okay. there may be, because this is evolving process, there may be some more normal form, okay. But but the in real time project, guys, I think if you are done, I mean, at least maximum third normal form or max to max BCNF, right, up to this normal form, if you are aware that, I think, I have never seen any project which is actually going beyond BCNF, right? So BCNF optimization, if you have done, or the normalization you have done, you are good enough for any sort of applications, I think, right? So this fourth normal form, fifth normal form, sixth normal form, these are also there, but I have not seen any practical usage of these normal forms. So today, in this session, maybe we will try to cover up to BCNF, and these are the prime important normal form. And interviews also, I do not expect somebody we are asking you, fourth normal form, fifth normal form, or sixth normal form, because they are not really practical enough, right? I mean, they might be. I'm not denying that they are not being used, but at least I have not seen, and this is at least, I would say 90% projects do not use beyond BCNF, right? BCNF is good enough, right? And so we will try to understand 1NF, 2NF, 3NF, and BCNF in this scope. Okay. All right. So what all these normalizations are, guys, okay? First of all, we will try to understand little bit about each of these normal forms, okay? And then we will go to the practical examples, okay? So let's try to understand 1NF, or the first normal form. So what first normal form says, guys, okay? It says it has certain rules, okay? So they are talking about a table, and in a table there will be column, right? So table is also called relation, right? In RDBMS, table is also called as a relation, and columns are also called as tuples, right? Or attributes, correct? Okay. So few things before that I want to just, I think I have already covered it, but I thought that you should keep that in mind, guys, okay? A few things. Let's brush it up our basics before we go, because all those concepts we are going to use. So first thing is primary key, right? So what is primary key, guys? Primary key basically, um, the simple definition for primary key is basically unique plus not null. Okay. When I say unique, means this particular key is nothing but a column or set of column, right? It can be a single column or it can be set of column, which should be unique, means every value in this particular primary key in particular field should be unique and not null. Okay. So this is the definition of the primary key. So you should be knowing what is primary key. And second is the candidate key, guys. Candidate key. So candidate key is basically, you know what, candidate key is also primary key, but let's say there are more than one primary key, right? More than one primary key. So the other primary key, which is also which can also have the ability to act as a primary key, is called the candidate key. All right. So that is candidate key. And also, guys, you can say that there can be more than one, candidate key. All right. uh, More than one candidate key in a table. So one will be primary key and other will be alternate key, right? So these are just definition, guys, but the idea of the candidate key is also it should act as a primary key, which means it can it can basically determine the unique record in in that particular table. Okay. So for example, if I just take the example, okay, so let's say in a company, okay, in a company you have employee ID, okay, and then you also have a PAN card, right? PAN card number, and then employee name, correct? And then obviously salary or whatever, let's say department, guys, okay? So when I say employee ID, this is always a unique, isn't it? It is a primary key, correct? And then when I say PAN card is also unique only, right? Because PAN card for each and every individual in India, or let's say Aadhaar card, I will say, guys, right? Aadhaar card. Aadhaar card in India. So Aadhaar card is also a primary key itself, right? It is not like it cannot differentiate the record, right? So every record can be distinguished uniquely using this Aadhaar card also. So this is also primary key, right? But in a table, we can mark only one key as a primary key. So this will be a candidate key, right? Candidate key. Let's say this is primary key, but essentially this is also a candidate key, right? I mean, this is also a candidate from the for the primary key, right? So in this case, this is a candidate key, and so so this is a candidate key, right? But this is also this can also act as a primary key, right? Okay. So I hope you are clear about the candidate key. If not, guys, I have done the detailed video on these keys. I think in the database playlist. You go and watch that so that you can you can be clear about it, right? And then, guys, there is something also called super key. Okay. So super key is nothing but, guys, okay, let's say you have a candidate key which can obviously determine the whole row, I mean uniquely, but you also add some different key. Let's say you are actually doing employee name also together, so this can be a super key. So in this case, let's say Aadhaar card plus employee name, right? So this is a super key because why super? Because you are actually taking some additional column also, which is not really required, but actually you are taking some additional column to form a key. Okay. So this is called the super key. All right. Now something a bit more about it. So guys, let's say I have this three, four columns, right? So department name maybe here, right? Four columns here. So in this case, for this particular, let's say this is the employee table. Okay. For this particular table, which are the primary key, which are the primary, let's say I am making primary attributes. So let's say, for example, I'm making a candidate key here, and in this case, I'm just going to do employee ID. I'm taking employee ID and Aadhaar card. Together, I'm making a primary key, let's say. Okay. Primary key or candidate key, guys, you can use alternatively. Don't worry about it. Okay. But what we are doing, we are actually taking those two columns to make a primary key or maybe candidate key. In this case, these two attributes, okay, which are part of the primary key, are basically the prime attributes. They are called as a prime attributes. So just know this, prime attributes. Okay. They are called the prime attributes. And these two columns, which are actually dependent on the primary key, are basically, these are called non-prime. Okay. I think hope you are clear, right? So non-prime, why? Because they are actually dependent on the primary key, are the primary attributes, right? Because see, name and department number is not independent one, right? I mean, they are actually, they have the existence because of some employee ID or Aadhaar card number, right? So that is the reason they are the non-prime column. Hope you are clear about this, I think, and now we are fully set to go ahead with this normal forms now to understand. Okay, now let's try to move further. All right. Now let's try to understand first normal form. What is first normal form, guys? Okay. So let's try to understand first normal form. What is first normal form? So I say uh, first first normal form. First normal form. So these are, as I said, that the normal forms are nothing but they are rules, right? So certain rules which are actually defined by various this database designers, or I would say the inventors and the people who are actually who has defined these databases, and these rules are in these forms, right? 1NF, 2NF, 3NF, BCNF, and then up to 6NF right now, and they are still evolving, right? So first NF says that this is applicable on a table, guys, right? So in a table, okay, um, in a table, okay, I can just do one thing, mixing of the data type, right? Mixing of, okay, let's do one thing, the best one, the very first one, right? So first one says that the every, what it says, that every uh, column, should have atomic value. Okay, atomic value. I'll tell you what is atomic value, right? So this is the first rule. Second rule is basically the mixing of data types is not allowed, not permitted. Okay. Third one is basically uh, every okay table should be should have primary key. Okay. There are the three rules essentially that we need to follow here. Okay. So for example, if I take an example, let's say employee example, employee table, and I am doing just employee name, one column, and then I say employee, okay, department number, and then designation. Okay. Okay. All right. Probably it will make more sense if I put it here. Okay. Designation. Designation. Okay, right. So let's say this is the employee table and we have three columns. Okay, one column is employee name, designation. So let's say one, and then this is software engineer. Okay, and then you have department number 10 or maybe IT. Okay, two chartered accountants, department is finance, right? Oh, sorry, not two. So here maybe let's say Akash. Okay, his name is Akash, and this guy is Akash. Okay, guys, let me do one thing. I have already noted down the example. That is better to take that example. Okay, I'll take this example, guys, first. Okay, I already have it, right? So let me explain it, guys. Okay, so what does it mean basically? So the first says that every column should have atomic value. Okay, so when I say atomic value, guys, the value which cannot be further divided into any other value. For example, here this particular table, let's say I have designed this table and I want to check whether this particular table is in first normal form or it is following the first normal form or not, right? In that case, what I am going to do here is basically I am just trying to check the first rule whether the every column is having the atomic value or not. So here I see that employee name, is it atomic? I think probably this is also not atomic. Why? Because this particular first name, e name, can be further divided into first name and last name, right? So that's why atomic value, it is not in atomic value. Atomic value says that you cannot further divide that particular value into any further uh, division. All right. So here employee name is divided into first name and last name, right? Fine. Now location. Location is basically combination of, the city, state, and then country, right? And here also we can divide this particular location, right, into multiple other column, and then hence this is also violating the first rule of uh, what is that, the first normal form, right? Every column should have atomic value. So this is also not there. Now what I have done to fix this thing, right? Because I want to make this particular table into first normal form. Then I have actually done what I have done. First name, I've divided name into first name and last name, and then this particular designation is okay. I think this cannot be further divided, and the location can be divided here into this three, right? So location is like city, state, and country. You see here, right? Let me. Okay, I hope you are able to see it, right? Perfect. Mm, a bit. I think it's okay, I guess. Fine. So you are able to. Let me reduce the size, guys. I'm struggling with this. Let me see if I can go to view and see if I have this option to. Yes, perfect. Zoom. I think I'll do it 75%. I think it will work now. Hope you are able to see. No, I think it's too small. Okay, I will just try to make it at 90%. I think 90 will work. Perfect, guys. I think 90 is okay. I think it's properly visible now. Okay. Yes. Perfect. All right. So this is how we actually try to remove this. We try to satisfy this atomic value, right? So now this is in. So this is the first rule, right? About first rule. Second rule says that we should, what we should not have, we should not have the mixed data type. Okay. So mixing of data type is not permitted in a column. Okay. So in this column, if you see, this is the mixing of data type. So this is completely integer and these are like a character, right? Alphanumeric, and this is completely numeric. This is not allowed also, right? So this data type, we cannot have it, right? So in that case, what I'm going to do is, basically if you see here, uh, this guy, okay, so we have to actually find something replacement. So this is actually violating that, right? So we have to fix this somehow. We have to find out what is the correct value and then we have to insert it. Okay. So this is also violation, one of the violation. Okay. Also, third rule for one NF says the table should have the primary key. Okay. So in this table, if you look at carefully, do you see any primary key here, which can actually uh, which can uniquely identify each and every record here? I think there is nothing, right? We don't have any primary key here. We have name. Name can be, it's not unique because two people have the same name, right? And it's quite possible in an organization, right? So there is no unique key here, or what I would say the primary key here, right? So what we have to do is we have to see. So this table is not satisfying the third rule, that says that table should have the primary key. So here we don't have. So what we have to do is we have to actually introduce one primary key, okay, which is employee ID. So here employee ID is a primary key basically, guys. Okay. So one, two, three. So we have to give the employee ID to each of. So after fixing this, guys, I think we can see this particular table is in one normal form now. Okay. So this is all about first normal form. All right. So let's move to the second normal form, guys. What is second normal form? So now second normal form, it says second normal form. Okay. I want to just put it here. Second normal form. Okay. Second normal form says that there should not be um, there should not be partial dependency. Okay. What does it mean by partial dependency? Partial dependency means, let's say I have a table T and I have three columns A, B and C. Okay. Three columns A, B, C are there. Okay. In this case, let's say I have the primary key or the candidate key. I will say this primary key or candidate key, both are same only. A and B, these two columns are forming a primary key. All right. If these two columns are making primary key, then C should be fully dependent on AB. Okay. So C should be fully dependent on A and B, because primary key is made up of using these two columns, okay, not only single column. If I say that as part of my functional dependency B is dependent on C, in this case this is wrong, because C is not only dependent on B, C is dependent on A and B together, both, right? So this is basically this is a case of partial dependency, guys. Okay. This is case of partial dependency and this is right. Okay. All right, guys. So let's take the example and try to understand little more about it. So in this case, if you look at this student detail, right? So this is the table, okay? And I want to check whether this particular table is in two normal form or not. So first condition should be basically what it should have. The first condition should be, guys, anyways, it should follow one NF. It should have It should follow first normal form, then only we can check for the second normal form. Okay. So it should have first normal form already. First normal form. It should already be there. And then second thing is there should not be partial dependency. So I am assuming that uh, it is already in first normal form because I am going to check whether this is in second normal form or not, right? So so in this case, I want to check whether do we have the partial dependency or not, right, as part of 2NF. So I see here student ID, course ID. So here student ID and course ID together is making a primary key. Okay, together making primary key. So in that case, what is happening? Let's say we cannot actually in this table student ID and primary key because we have the course fees also, right? Course fees has nothing to do with the student, right? So the course fees is completely dependent on course ID. That's why we have student ID and course ID, which two are making a primary key, and then these two are the non-prime. So these two are prime attributes, student ID and course ID, because these two are making a primary key. And the column which are responsible to making a primary key are candidate key or the prime attributes, and these two course fees and marks obtained, these two are the non-prime attribute. Now what it says, the second normal form says that there should not be a there should not be any partial dependency. When I say partial dependency, it means that there should not be partial dependency means no non-prime attribute, okay, should depend on no non-prime attribute should dependent on part of primary key. Got it? Part of primary key. So when I say part of primary key, here you see the primary key is made up of this A and B, but it is actually we are saying that this C, which is non-prime, is dependent only on B. So in this case, if you see the example, if I see, say that this course fee, is it dependent on student ID? Do you think? Because course fee is same for everybody, right? Like it's a course fee. It is basically not dependent on student ID. It is rather dependent on the course ID. So let's say course ID is 10, and for this the course fees is 5,000, and this is going to be the same for every student, right? I mean it is, so if you see here, let's say course here also, right, the same. So for student ID 2 also the course fee is same. So if you see that course fee is not dependent on whole of this two primary, I mean two attributes of this primary key, because primary key is made up of this two column, but course fees is only dependent on course ID, which is nothing but it is partially dependent. The non-prime attribute is, or non-prime attribute is dependent partially on a part of the primary key. Okay. So this is a part of primary key. This is not whole primary. So this is called the partial dependency, guys. Okay. So as I said, the definition is each non-key must depend on the entire primary key. Okay. This is the rule basically. Okay. So non-primary key should depend. Okay. I would say like this, guys. Okay. The definition I'll say here. Each non-prime attribute, okay, or you can also say non-key, same thing, right? Non-key or non-prime attribute are same. Non-key should fully depend on primary key. Okay. When I say here, it means in this case it should depend on student ID and course ID. But in reality, if you see here, course fee is only dependent on course ID. It doesn't have to do anything with the student ID. So this table is not in two normal form, guys, right? Now the question is, can we check the other non-key attribute? So this is the non-prime attribute again, marks obtained. Do you think the marks obtained is fully dependent on student ID and course ID? Yes. Why? Because marks obtained, it is talking about a student has received this marks, and on which subject he has received? He he has received on this particular course ID, right? So this is the course ID, and in this particular course ID, the student has received 50 marks, right? So marks obtained is basically dependent on these two columns. So this is a fully dependency. So here it is satisfying the two normal form, but here this particular column, the course fee, it is not satisfying the second normal form, right? So we have to make sure that how does it satisfy. So we have to see, this is the way we can do actually. So we can actually break this table, okay, into two tables. One table can be student table, where student ID and course ID and then marks obtained, right? So this is the marks obtained, isn't it? This is the marks obtained, this guy, and this is obviously dependent on this whole primary key. However, in the next we can make one more column where I can segregate the course ID and course fees. So for each ID there will be corresponding course fee, right? So this is also in this table. This is the primary key, guys. Okay, so we have to design the table in such a way that the partial dependency should not be there. So in that case, this particular table, now this particular this now this and this are in, basically, this particular table essentially is in two normal form now, right? Because the non key is fully dependent on the primary key, right? Not a subset of the primary key. All right, so I hope you are able to understand this, right? And now we will go back to the third normal form now. Okay, we will see what is third normal form. So it is again one definition I'll tell you. So this says that no transitive dependency, guys. Okay, transitive dependency. So when I say transitive dependency, it means that, let's say A is a primary key, right? Primary key, and B and C, for example, C. Okay. So let's say A is a prime attribute or primary key, for example. Okay. And this is non-prime key, non-key. Okay. Non-prime key. Okay. And this is, let's say, this is again non-prime. Okay. In this case, what is happening, guys, here? A is actually B is dependent on A, which means B is pointing to A. A is a primary key and B is dependent on A. Now C is dependent on B, and it is also dependent on A. C is also dependent on A, but not directly dependent on A, right? So it is dependent through B, right? Which is which means that this particular non-prime attribute C, or non-primary non-prime column C, is dependent on non-prime column B. So this says that no transitive dependency. Okay, in this also means that no non-prime attribute, okay, should be dependent on any non-prime attribute. Okay, but it is here, right? In this case, one non-prime is dependent on other non-prime. That's why this is the violating the third normal form, and this is also transitive. Transitive means, guide, transition, right? It is transiting to this B, A is transiting to B, and B is transiting to C. But we cannot say C is actually, directly dependent on A. It is actually dependent on B. So this kind of things are not allowed, basically, right? So this is the rule about the third normal form, right? So let's try to see the example. I think that will make more sense. Okay. So this is the example, guys. Okay. So I have one table called student performance, right? In this I have taken three columns. One is student ID, marks obtained, and division. Okay. If you carefully observe it, student 1, student ID 1, and how much marks he has obtained? More than 35 and less than 45, then is a third division, right? So basically student 1 is third division because he has actually obtained marks in between this, and student 2 has got more than 60% or equal to 60%, so that's why it's first division, third division. So these are the category, right? First and second and third division, right? Now if you look at it, what I said, transitive dependency. So here in this table, column, this is the primary key, student ID is primary key in the student performance table. This is actually um, so marks obtained is dependent on the student ID, because this student has got this many marks, and in between these marks, it's just a range, right? It's not exact number, but this is just a range, right? So student has got the marks between this, which means it marks obtained is actually directly related to student ID, right? However, if you see this division, so division is actually okay in a way, student ID 1 or student 1, 2, 3, they have actually got this division. Okay, it is something like okay, student 1 is in third division, student 2 first division, student third has got the second division. But if you see that this is not directly related to this, right? So this third division, first division is derived from the marks obtained, isn't it? Correct or not, guys? So this is basically, this has nothing to do, I mean, it is not directly related to student ID. Division is not directly related to student ID, but it is actually directly dependent on marks obtained. That's why I say this is A, this is B, and this is C. So A is dependent, B is dependent on A, and C is dependent on B. So this kind of dependency is not allowed. So this is called transitive dependency. Transitive dependency is not allowed here. So what we have to do? This is definitely in not in third normal form, right? So what we have to do, guys? We have to actually segregate this into two tables and make sure that we resolve this dependency. Okay. So what exactly we have to do here is we have to take these two table, because these two are closely dependent on student ID and marks obtained, both the columns are can go into one table, and other two like marks obtained and division, because division is decided based on the marks obtained, how much marks obtained in between what range, right? So these two can go into the other table. Now we are actually sorted out this particular dependency. So this is how we can actually remove the third normal form. Okay, so I hope you are able to understand this, and let me write the okay, so non okay, I have already written, right? Should not be dependent on this. So every non-key, okay, every non-key should be dependent on fully on the primary key. So this also means that otherwise, right? So non-key, non-prime, okay, non-prime attribute should not be, should, I think it should be no actually. No non, so this definition also you can actually take. No non-prime attribute should be dependent on any non-prime attribute that we have seen, right? This also means that, this also means that every every non-prime, every non-prime, or also you can say non-key, okay, in a table should depend on the primary key. Primary key, or also you can say candidate key, guys. Okay, alternatively. All right. So hope you are able to understand this. So hope you are able to understand this third normal form, right? Now, guys, there is the last one that we are talking about, the BCNF now. Okay, we'll talk about BCNF also. That is BCNF, Boys Code Normal Form, and this is, guys, this is as I explained here, I think in the beginning. If you look at here, right? So this is BCNF. This is not fourth normal form. BCNF is also called as, it is something in between third and fourth normal form, right? So this is also, I mean, some people call it as a 3.5 normal form, right? 3.5 normal form, okay? People call it like this because this is a strict, or I will say stronger form of third normal form. Okay, what basically it does, I'll tell you why do we need BCNF here, right? So first of all, we need to understand, BCNF is a stronger form of 3NF. Why it is called? Because in 3NF, what we say, let's say I have A, Okay, in this case, what was that? Student ID, right? Student ID. Let's say it is A, and then you had what is that? Course ID, course ID, right? Course ID, not course ID, guys. Uh, this one actually. I'll just take this. All right. So here, okay, fine. So this is dependent, and this is also dependent. So this I call as A, and this I call as B, okay, and this is C, okay. In this case, what is happening? B is dependent on A and C is dependent on B, but ideally this is not allowed, okay. In this case, let's say, in this case, this is non-key actually, right? So this is non-prime key. Okay, this is non-prime key, and this is also non-prime key. So, and this is prime key, okay. So what we said that the non-prime key cannot be dependent on any other non-prime key. Here C is dependent on B actually. So this is not allowed, that we have discussed in third normal form, right? Third normal form. This is perfect, okay? Now, why do we need BCNF, guys? Where we are trying to put more stricter rules here, right? So in this case, let's say, in this case, if we have, so in this case, let me try to put something like this. So in this case, let's say this is a prime column. Okay, this is a prime column. When I say this division, not division, I think let's say you just imagine that. Okay, now B is dependent on A. Okay, this is perfectly all right. Okay, non-prime is dependent on prime. This is perfectly right. Now, in this case, if uh, one prime is dependent on non-prime in either way, right? I mean, this can also denote like this, right? So this can also be like this. So basically, prime can be dependent on a non-prime, which is actually in principle this is wrong, right? Principle, this is wrong. None of the prime key can be dependent on non-prime key, right? But if this kind of situation is there, then this is actually following the three normal form. This will already be in three normal form if this kind of situation is there. I mean, the only condition for third normal form is one non-prime cannot be dependent on other non-prime. But other way around, one prime can be dependent on a non-prime, that is allowed. Okay? In principle. This is okay? As per rule. As per rule, this is allowed. Okay? But if you see, I mean, this should not be the case, but this is in three normal form already. Three normal form. Okay. So, but this is as per rule. I think this is not the right way, because the primary key or the primary column should not be dependent on any non-prime key, isn't it? So, to just to restrict this, we have come up with BCNF. Okay, so in BCNF it says that every left hand side in the relationship, every left hand side field should be a prime prime attribute. Okay, what does it mean? It means that here, if you see, the left hand for this particular relation is non-prime. So this is not allowed. So this BCNF, it is not allowed. So it can only be possible. So which means that every left hand side, which means left hand side means left hand side of this arrow, right? This should always be primary column. But in this case it is not, right? Right? So hope you are able to understand it. And this is what the BCNF says. Okay? Now, just to maybe let me try to give some example if I can establish something here. Mm, 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 mm. Not here, guys, but I hope you are able to understand it, isn't it? Let's say I'll just take example A, B, and C. Fine. So A is prime, okay, and so the relation can go like this. Okay, B. Okay, and B is a non-prime. Okay, this is already non-key or non-prime. Okay, non-key, non-prime. Now, what I can do is, mm, in this case, B, which is non-key, okay, can be dependent on C, okay, which is prime. I'm just taking example, okay, this is prime, okay. So this kind of relation is allowed. This is kind of relation is allowed in 3NF, okay, 3NF. But in BCNF, 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 we are actually not allowing this kind of situation. So what we are saying, A should be dependent on B. That is perfectly all right. Okay, because A is prime. Okay. Now, uh, sorry. This arrow should be this way actually, which means C is dependent on B. So this is not allowed. Okay. What is allowed in BCNF is it should be, let's say B is there. Okay. B is there, and if B is okay, C is actually pointing. So this is, let's say, non-prime key, non-prime. This is prime, and this is prime. So this is allowed. Okay, this is allowed in BCNF because one primary key, the primary key should always be in the left-hand side of this arrow, which means this is actually this is this is not dependent on any non-prime. Okay, every non-prime is dependent on this prime attribute. So this is the BCNF. But if you look at here, um, the arrow is other way around. So arrow is there in the B, which means it says that the prime C, prime column C or prime attribute C is dependent on B. So this is actually allowed in B3NF. This is allowed in 3NF, but BCNF does not allow this. It says that the arrow should be other way around actually, like this. Okay. So this is what the BCNF. I hope that, I think it was a long session, guys, but I thought that I will try to explain it so that you can be very clear about these concepts, and hopefully I was able to do. And for 4NF, 5NF, and 6NF, maybe I will try to see in future. If I feel that if you guys really needed video, do comment on this video so that I can come up with that. If some of you have faced any sort of interview question on the fourth or fifth or sixth normal form, I'll cover. Otherwise, I do not think that we should essentially cover that from the interview point of view. Okay, so that's all for this video, and I really hope that this video will really add up to your knowledge, and it will be helpful for you for your career or project or maybe interviews, right? So that's all for this video, guys. Thank you for watching, and happy learning, guys, and God bless you. Bye.